Hello everyone, I'm very excited to be with you and talk about multi-regional serverless applications today. In this session, we'll be looking at what you need to consider when you're going multi-region with serverless in the context of a real-world serverless application. We'll be looking at why the owner of this application would want to go multi-region serverless. We will also look at some of the patterns that the owner can use to go multi-region with the application based on the use case, and we'll do this one service at a time. So let us first look at the application in question. We have this made-up company, Food for Thought, that allows its customers to order food from any restaurant close to them and get it delivered. The customers obviously need to be able to browse the different restaurants and what they have to offer. When they're happy with the order, they should be able to submit it and get the food delivered. The company is doing healthy business across both North America and Europe. They want a great customer experience, so no matter where the customer is located, they should experience low latency and the application should keep up with demand. Customers do not randomly order food during the day, but instead concentrate the demand during meal times in whatever time zone they happen to be in. It creates two critical requirements for the company. They should be able to handle highly variable load during the course of the day. It also heightens the criticality of being available during lunch and dinner times, since it will provide the bulk of their revenue. This type of use case is a great fit for serverless. Especially the last two things I mentioned are directly addressed by the benefits in the gray box that you see on the screen. The ability to scale with usage and the availability and fault tolerance built in. They're also excited though about the lower overhead of not having to manage servers or the reduced cost of never having to pay for idle as well. So with these great benefits, why would Food for Thought want to go multi-region? Well, first, going from Europe to North America to access the application would include a latency hit. So having the application available in a region close to the customer would allow for improved latency and performance. And as I mentioned, the availability of the application during meal times is critical. So they want to increase the fault tolerance. So it's higher than it's possible to do in just one region. Whenever they're dealing with personal information about their customers, they might also have to adhere to laws that specifies how to manage that type of data. For example, there might be personal information originating from a country that has to stay in that country. Now Stefano will go into a little bit more what they have to specifically consider for Food for Thought.
Thank you, Magnus. Hi, everybody. I'm Stefano. When deciding to go multi-region, teams don't work in isolation. This is a decision that needs to be made alongside the business stakeholders. It will involve significant complexity for developers. It changes the way you write applications and the way you operate the applications. It will also introduce some trade-offs in the user experience of the application. When you're designing multi-region applications, it helps if you use microservices in your architecture. It is much easier to bring a simpler service to multiple regions than port giant monoliths and stand them up in every single region. In our example, the Food for Thought application consists of three key services. First, we have a service that allows end users to browse the list of restaurants and look at their menus. This service also allows administrators, ourselves, the developers of the applications, as well as our partners, to manage their catalog and their menus. The final service is the order processing service. This is the core of our business. This is where we accept orders from our end users, we process payment, and we send them off to the restaurant. We'll treat each one of these individually. As Magnus and I designed the application and the reference architecture, we created this decision tree to help us think about each service and guide our decision on whether something needs to be multi-region or not. The first question we ask is, what are the latency and availability requirements for this service? Is it core to our business? Can we operate and generate revenue even if the service is not available? A good example of this would be a business intelligence service, where we collect all transactions data and we make them available to our business users through reporting. It's a great service to have, but given that regional outages are unlikely, and even when they do happen, they're normally short-lived, we probably don't need to replicate this data and take on the additional complexity of having this service in multiple regions. For other services that our users interact with and that we need to operate, well, then we need to go to a multi-region architecture. And there, the technology team is presented with another choice. How complex do we need to make this service? Is it enough to have a master region and a read-only slave? Or do we need to go with an active-active or master-master setup? If you've tried to operate databases before, you know how much having a master-master setup increases the complexity of your application. The other consideration that will be very important for business user is, how does my cost structure change when I go multi-region? There's a few items to note here. First, because we are using serverless offerings from AWS, Lambda and API Gateway, our compute costs don't change because both Lambda and API Gateway only charge you when your code actually executes as it processes requests. So no matter how many regions you're in, your traffic is still the same. Your costs are tied to your business. When it comes to persistent storage, database or files, then you need to make a consideration, because you need to decide how much data you want to replicate. Do you need to replicate it all to the second region? That would double your costs, and on top of that, you need to consider the compute resources necessary to create this replication. And finally, data transfer. Data transfer out is similar to our serverless consideration in the sense that it's tied to the traffic you receive, and that doesn't change no matter how many regions you're in. However, different regions have different costs for data transfer out. So it's always good to keep an eye on those numbers before picking the regions you'll operate in. Like I mentioned before, going multi-region also changes the way we operate our software. Where before we could have done with an operator running perhaps a deployment script from a server somewhere, we now need to make sure that everything is automated because our application is so much more complex. We need to make sure that all of the metrics are collected for each region, so that when an alarm sets off, our operator knows exactly where to look. It knows which region and which service it needs to look at. And finally, logging. In the event of an entire region being lost, we still want to be able to access those logs to know what went on. And so it's important that we keep in mind that these need to be replicated. Finally, like Magnus introduced, in certain countries there are laws that require a user personal information to reside within their country of origin. And so a classic example of this would be a German customer registering with our application. It is easy enough using Amazon Cognito, one of our serverless offerings, to create a user database in each region. And when our user from Germany registers from their house in Germany, we will likely direct them to our application hosted in our Frankfurt region. However, there are edge cases around it. For example, if the user travels to the US and tries to access the application in the US, our DNS load balancing is likely to direct them to our US deployed application, where we shouldn't allow them to alter their profile or touch their private data. And so this brings us to another point, which is, while we can make our application multi-region, and we can make sure that the DNS gives almost always the right answer to the user, we also need to make sure that the client has some smarts in it to allow it to deal with these edge cases. Now that we've gone through the consideration, let me hand it back to Magnus to talk you through the first services.
Yes, so let's just start looking at the browsing and updating catalog use cases. The browsing use case allows the customers to look at restaurants and their menus, like we mentioned before. It is critical that this functionality is available since it's a step in them placing orders. This is part of generating revenue for the company. On the other hand, updating the catalog of restaurants and menus is not as critical. Customers can still place orders even without some late-breaking changes. With the same line of thinking, we're okay with eventual reconsistency. The critical part is the ability to read the information, not to quickly being able to update it. So if we run the first use case, the browsing the catalog use case, through our decision tree that we showed earlier, we can definitely say that this is core to our business. We will put this into multiple regions, leveraging multi-region DNS routing. The use case is a read-only use case, but we do need to get updated information from the next use case, the update use case. The scheduled replication provides too much latency in the separate updated use case, so we're using the near real-time eventual consistency from a master copy instead. Looking at the second use case, we will stop much earlier in the decision tree. As mentioned previously, the updating use case is not critical, so we can simplify our architecture by limiting it to a single region. This is an important realization as it helps us avoid complex setups like master-master replication, something that would likely be required in the case of this, these updates being a critical process. Looking at the architecture for browsing catalog use case, it's fairly straightforward. We have our DynamoDB tables on the very right. They're updated in a separate use case as mentioned. Those are accessed by the business logic in our Lambda functions that then are exposed via REST API provided by Amazon API Gateway. The mobile client is accessing the REST API over the internet using Amazon Route 53 for DNS lookup. So a few things to highlight here. We have an active-active multi-region API setup, where each region is taking traffic at the same time. The mobile client will access the REST API that is closest to them based on latency. Each region has the exact same setup. You deploy the same stack and code in each region. Since we're only doing reading, the Lambda code can restrict itself to only read the DynamoDB tables in the local region. An optional thing here too, if you discover that part of the public API works well with caching due to its static nature, we can also put CloudFront in front of the API to speed up the delivery. Let us go into more detail on the active-active setup. We're able to do this by leveraging a recently released feature of the Amazon API Gateway. It introduced the concept of endpoint types. Edge optimized is the type that we had before, where CloudFront is used to being the endpoint close to the client. The newly introduced regional endpoint type places the endpoint within a region, but also allows us to create duplicates of the API in other regions. One of the key concepts here is to make this work is that this applies to custom domain names as well. So we can create a domain name for an API, for example, in this case, api.foodforthought.com. We can do that in each region. as now custom domain names are now unique per region. Looking at diagram for this. So when you create an API in a region by using the regional endpoint type, we'll have an API endpoint created in that region. If you see in the diagram the API endpoint circle. This is an endpoint with an auto-generated domain name. That is a customer you cannot customize. However, you can put a custom domain name in front of that API endpoint, and that you can give its own specified domain name. You will use that domain name endpoint in combination with Amazon Route 53. The endpoint identifier will be entered into Amazon Route 53 as an alias or CNAME record, and as you will have one endpoint per region, you will add multiple alias records, one for each region. You can now leverage all of the Amazon Route 53 capabilities to route and failover between these endpoints. For example, latency and geolocation routing. This allows for an active setup with failover. You do need, though, to implement regular Amazon Route 53 health checks as part of getting the failover capability to work. One way to do that is providing a specific API resource that the health check can call, and it's recommended to have that API resource do a deep ping, essentially checking for all the different components and make sure all the different components are healthy. Let's also take a quick look at the updating catalog use case. It looks very similar to the previous case, but now we're only using one region. The one on top is the one that's active, kind of showing the bottom one a little bit shaded, kind of hard to see here, but it's a little bit shaded. Is kind of representing some of the browsing catalog resources. The DynamoDB table in that master region in US East 1 is considered to be the master table. And we're using DynamoDB streams and Lambda to replicate the data in the other region. So the summary here is we have a single region API, right? So the criticality here is lower, so we can do that. We still need to replicate the data, though, so it's available in the browsing catalog use case. And using a master-slave setup is a great fit, since it will simplify the solution and avoid any complication with a master-master setup. Things like data conflicts or a split brain. We can easily set up replication from one region to another by leveraging DynamoDB streams and Lambda. Lambda can use DynamoDB as event source out of the box, so any change to the DynamoDB table will be sent to a Lambda function with change records put into the payload of the Lambda function. Then the Lambda function can iterate over those records, connect to the DynamoDB table in the other region, and replay the updates. Now Stefano is going to go over the next use case, the submit order.
Thank you, Magnus. Submit order is the core to our business, the ability to accept orders from clients, process them, send them to the restaurant, and accept payment is really our entire business. This is our kitchen, and our kitchen needs to keep cooking no matter what. Otherwise, our customers don't eat and we don't make money. So it's critical that the service is always available and that we can accept orders for any region at any time. In this order processing service, we also have an external dependency, our payment processing system, and we'll go into that a bit later on. So if we look at our decision tree here, the first answer is pretty clear and straightforward. Yes, we absolutely need to go multi-region. And we need to be able to accept orders for any customer in any region. If we were to lose the Frankfurt region in Germany, it would not be acceptable for us to stop operations completely in Germany. We would need our US region to keep operating and accepting orders for the German restaurants. As a developer, when I get told about this service and its requirements, I tend to get very excited. This is a complex problem. And I always think that I'm going to build a perfect solution to it, a software that is beautiful, replicates itself. However, in the real world, once it's deployed to production and I begin operating it, it often turns out that my beautiful baby is a little bit of a Frankenstein. And that is because master-master replication across region is not viable. Speed of light being what it is, does not allow us for acceptable latency while building a true asset transaction across multiple regions. We've explored a number of different approaches with Magnus, and I will tell you about the ones we discarded later on in this webinar. What we've decided to do is to strike a compromise. Any region will be able to accept an order for a customer. However, once the region has accepted an order, that region will flag itself as the master region for that order, the home region of the order. And what that means is that order data will be replicated to other region and can be read from other region. But the order confirmation and processing can only happen in the master region of that order. The clear benefit of this is that it keeps our application simple. We still need to think only about a single region when we build the order processing. However, we also limit the blast radius of potential regional outages. And that is because there is only a fraction of a moment where our application is in an inconsistent state. And that is in between the customer saving the order and hitting the submit button. If we were to lose the region in between those two actions, then we'd have to ask the customers to restart the order. In all other cases, we'll be able to continue as if nothing had happened. Like I said in my introduction, going multi-region increases complexity, and because of that, no matter what, it will require you to strike a compromise between user experience and the technology you can feasibly build and reliably operate. And this was our compromise. We decided there was one use case where we would not allow inconsistent orders. They would need to go through the master region. If that were to happen, we would simply fail fast and tell the end user, I'm sorry, we could not process this order, please submit it again. And connecting back to what I was saying at the beginning, our application is smarter, is not just a dumb client of the APIs. It includes the logic to work around these edge cases so that we can keep a smooth user experience even during outages. So let's take a quick look at how this works. The way we envision it is that the client will first send a request to create the order to our endpoint, api.foodforthought.com. Route 53 will direct the client to the closest region, or regardless, the best region for the end user. Once that order hits the end region, our application will accept it, save it in our database, and assign it a unique identifier. From that moment on, the region that received the order, in this case US West 2, sets itself as the master region for that order. The order data will be replicated to the other region, but only US West 2 will do the processing for that order. We've done another thing to make the application simpler and a bit more stateless. Instead of picking a generic auto-increment numerical identifier for the order, we decided to generate more complex IDs, similar to our Amazon resource names, the ARNs. When you create an S3 bucket or start an EC2 instance, you can see that the unique identifier for that resource, it includes a lot of information. It includes your account ID, it includes the region it's running in, path, and any other detail that may be helpful for the software to make decisions. And so our order identifier includes a numerical order ID, a region, and the identity of the user that created it. By having all this information, both our backend application and the client can make smart decisions. If the backend receives a submit order command for an order that is in a different region, it can quickly respond and say, I can't help you with this order, without having to query databases or check other regions. And same story for the client. Just by looking at the order ID it receives, it knows which region to address to submit that order or make edits to it. And so once we have that unique identifier, our client can go and talk directly to the master region for the order and submit it for processing. This is the higher level picture where you can see that the first step is querying the DNS, Route 53, that will send us to the best possible region. After the order is created, the client will address the individual region that is the master for the order. If the edge case where between the order being created and the client sending the submit command, we were to lose the order, that's when the client would fail and say, do you want me to submit the order again? And it will restart the process without keeping any historical state on the previous version. It will simply go back to Route 53, who will know about the issue from its health checks, and send the order to a different region. The other interesting point we have in this slide is our dependency, that gray box, the payment processing system. I have drawn a single endpoint for the payment processing system in this slide on purpose, because the point I want to outline is that your application is only as good as its dependencies. Your availability will be only as good as that of your dependencies. Having a single endpoint for a service that uses multiple regions defeats the purpose of using multiple regions. Because if that endpoint is down, you have a cascading effect that affects all of the applications you run. Some of the other options we looked at when we were considering building a truly master-master consistent read and write application. The first one was obviously pessimistic locking. However, the latency to lock records in all regions for an update was too much. It would have failed our requirements in SLA. And so we moved on to quorum-based algorithms, both for writes and reads. On the first downside to this is that we would have had to use a minimum of 3 regions. You can't have a quorum with just 2. For write quorums, we would have still taken a latency hit because we would have had to write to a minimum of half plus 1 of the regions we run. And for read quorums, it was still a latency hit because the endpoint the customer was communicating with would have had to query multiple regions. Ultimately, it would still fail our SLAs. The last option was CRDT, conflict-free replicated data type. We could have used a vector clock on the order record in each region to make sure that we were working on the latest version and successfully synchronize the various regions. However, this would have introduced significant complexity into our replication algorithm, and it would have incrementally increased the number of potential edge cases during conflict resolution. We felt the complexity was not worth the gains for this. And so to summarize the order service, we do have an active-active multi-region API where any region can accept orders for any customer. The trade-off we've decided to make is that once the order is created, it needs to be processed by that region. To address this and maintain a good user experience, we've decided to make the client a little bit smarter so that it can go and address directly the master region. And it can handle the failure case where the region goes down before it had time to submit and process the order. And finally, we made the primary key a bit more complex than a simple number to include all of the details both the client and the server need to make quick decisions about a request. And so to conclude our presentation, this is what we want you to take away. When going multi-region, you need to be extra careful about what your requirements actually are. If you are using a service-oriented architecture, if you are running microservices, then there's a good chance you don't need all of them to be multi-region. If you don't, then don't take on that complexity. It makes the software harder to write and much harder to operate. The other trade-off is that, as we observed with our pessimistic locking and quorum-based algorithm, a true master with a consistent read and write, it's hard to write, and it can result in a worse customer experience because you're increasing the latency on your application significantly. Sometimes it's better to fail fast and write your software in such a way that customers can pick up their original state with a single click from their client. The final note is around operations. We talk about Route 53 health checks and setting up aliases so that they direct customers to the right region based on latency. However, as you do this, all operations in a multi-region service must be automated. You're taking on so much more additional complexity that you cannot rely entirely on a human operator anymore. At AWS, we have lots of services that help you with your monitoring and logging, CloudTrail for administrative actions, CloudWatch, metrics, and logs. When you deploy a service and you send it to multiple regions, make sure you are also deploying the metrics you require and the automated alarms on those metrics. You can use Lambda functions to respond to the most common alarms and take the most common actions automatically. And then you can use services like SNS to send text messages or emails to operators so that they can jump onto a problem as soon as it happens and they know exactly where to go because you have fine-grained metrics enabled. We've published a blog post that details the architecture for our application. You can find it on the AWS Compute blog. It's titled Building a Multi-Region Serverless Application with Amazon API Gateway and AWS Lambda. This blog comes with a GitHub repository for our reference architecture. These are great resources to get you started. Also take a look at the API Gateway documentation and see how regional endpoints work, the new feature that Magnus mentioned. And with that, we'd like to thank you from both myself and Magnus.